Hello, myself Jobin Johnson, registration number URK 19CS1034. So today I'm going to explain you the fourth experiment of OS Lab, that is to write the program to implement CPU scheduling algorithm for first come first serve and shortest job first, priority queue and round robin scheduling using C++ or Python. So I've used Python. Okay. So our first was first come first serve. Further, the algorithm is to take the input from the process along with their burst time and find the waiting time for all processes. And third is as first process that comes need not to wait. So waiting time for process one will be zero. That is, I have used waiting time list zero equals to zero. So finding waiting time for all the processes, that is for processes I, that is WTI is the waiting time. Waiting time of I equals to first time of I minus one plus waiting time of I minus one. And the find the turnaround time is for finding the turnaround time is equals to waiting time plus burst time for all processes. Okay, so for finding average waiting time, the oh, for finding average waiting time is equal to total waiting time upon a number of processes. So similarly, we have to find average turnaround time is that is equals to total turnaround time upon number of processes. So I have used first function for finding waiting time, as you can see here, and the second function I used for finding the turnaround time, and third function I've used for finding the average time. Okay, so as you can see, this is the code. So I'm taking process 1, 2, 3, and n is equals to length of process, that is 3 right now. First time is 24, 3 and 3. Find I've used the function as previously said. I've used for finding the average time. So n burst time. So the process 1, 2, 3, first time 24, 3, 3. So waiting time is 0, 24, 27. Turnaround time is 24, 27, 30. And the average waiting time is 17, and average turnaround time is 27. So shortest job scheduling algorithm is traverse unit all processes gets completely executed. So we have to sort all the uh, processes, then find processes with minimum remaining time at every single time lab. Okay, and the second is reduce time by one and check if its remaining time becomes zero. Then increment the counter of process completion. Then current process is equals to current time plus one is increment. Current time is incremented by one. So and the calculate waiting time for each completed process. Okay, so the waiting time I equals to completion time minus arrival time minus first time. Okay, so last step is to increment time lab by one. Okay, then find the turnaround time, that is equals to waiting time plus first time. Okay, so there is the as you can see is the implementation. Here is the implementation. So I have used the function finding waiting time for waiting time find the waiting time. I've used the function find waiting time, as you can see here, and I will use another function to calculate the turnaround time. As you can see, find turnaround time. And another function I've used for calculating the average time. That is find average time. As you can see, I've given the input. So average waiting time is 2.667 and the average turnaround time is 12.66. So third is priority scheduling. For that, the algorithm is first input the processor with their burst time and priority, then sort the processor burst time and priority according to the priority. Okay, then input the processor along with the burst time, as you can see. So find after that we have to find the waiting time for all processors. As first process that comes need not to wait, so waiting time processor one will be zero as usual. Waiting time zero is equal to zero. Then finding the waiting time for all the process, that is for process I, processes, that the waiting time I equals to burst time I minus one plus waiting time I minus one. So then the next step is finding the turnaround time. For that, the turnaround time equals to waiting time plus burst time for all processes. Okay, and after that we have to calculate the average waiting time, that is total waiting time upon number of processes. Similarly, we have to find the average turnaround time, that is total turnaround time upon number of processes. So here is the implementation. I've created as usual as previously. I created for finding the waiting time, created a function find waiting time, and another function I've created for turnaround time, find turnaround time to calculate turnaround time. Okay, and to calculate average time, I've created a function find average time. Okay, as you can see here. So for priority scheduling, I have used another function calling priority scheduling. Okay, so here as you can see, here's the all the means processor first time and the priority queue priority priority. Okay, then the as you can see, I have used priority scheduling function for calculating the priority scheduling previously as you see. So and so order in which process gets executed is 132 as you can see. Okay, so this is the output. So our last uh, scheduling is round robin scheduling. Okay, so the algorithm is to create an remaining burst time. Remember burst time. Okay, to keep track of remaining burst time of processes. So this array is initially a copy of burst time. Okay, then we have to create another array waiting time for storing waiting time of processing. Initialize the array is 0 right now as 0. Okay, so initialize time t equals 0, then keep traversing the all processes while all processes are not done. To following means the condition is if remaining burst time is I is greater than quantum, t equals to t plus quantum. Okay, then uh, burst remaining burst time is decreased by quantum. The quantum is a variable as you can see. I will show you in the code. So and if this condition is not true, then the else condition is else last cycle for this process is t equals to t plus burst time remaining burst time. Then waiting time I equals to t minus burst time I. The burst time remaining burst time is given 0. This process is over. So our implementation is we have created a function to calculate waiting time, that is finding waiting time. And for to calculate turnaround time, we have created another function find turnaround time. And another function to calculate average time, I created a function find average time. Okay, so as you can see here, I previously mentioned quantum. Here is the variable used quantum. Okay, so here as you can see, the average waiting time is 6.3 and average turnaround time is 60. I hope you understood. Thank you.